and then the nitrogenous waste urea. When the body takes amino groups off an amino acid, then this amino group can be converted into ammonia, which is very toxic. The liver takes this nitrogenous waste and converts it into urea, which is less toxic, but still the body must get rid of its urea. And so, when blood reaches the glomerular capillaries, the urea then passes through the fenestrations into the filtrate. It passes through the PCT, the loop of Henle, the DCT, and then the urea will then pass into the urine. So this is how the body excretes its urine, because it filters the blood and then does not reabsorb the urea.
Epithelial cells are constantly being shed from the epithelial linings of the body. And here in the urethra, the simple squamous epithelial cells, which are the most superficial layer of this epithelia, these cells are also being shed, and they can end up in the urine. This is not an abnormal scenario. As urine passes through the urethra, it can remove some of these squamous epithelial cells. This is normal.
It is also normal if transitional epithelial cells end up in the urine. Transitional epithelial cells line the urinary bladder. And as transitional epithelial cells are shed, as epithelial cells often are, they can end up in the urine in the bladder and then pass through the urethra. The presence of transitional epithelial cells in the urine is therefore normal and not indicative of a problem.
I am a hydrogen ion. I form acid. And acid is normal, so acid is in the blood and acid is in the urine. But its level can be controlled. So if the body has too much acid, one of the ways that it can release this acid is to excrete more in the urine. There is a sodium hydrogen ion antiport pump. So as sodium ions come in, the acid leaves, and so therefore the urine can be much more acidic than the blood that it originally came from, because the tubule cells can secrete additional acid into the urine.